All right, I'm gonna go through all 7 questions on this study guide just to kind of show you what to expect on your quiz coming up. And so let's just go for it. Let's start with number 1. It says identify the similar triangles and find x. Okay, so for the identify part, we're actually going to have to write a similarity statement, and they probably should tell us more about why they're similar, but I think we have enough to see what sides go with what or what angles go with what. And so I'm going to use the highlighter to just kind of show you. The first thing I see is like this is clearly the long side, and so is this. And if we're expected to find out what x is, it must mean that these two go together, because we have information about both of those. They couldn't give us information about 5 and then have it go with this one. We wouldn't be able to solve it. So that means that these two sides must go together then. So with that, we can make a similarity statement, and all that means is triangle, let's say ABC, is similar to triangle. Now we have to go over here. We have to say, okay, A is the corner between the green and the yellow, so that must correspond with E. And then we went from A to B, so A to B goes along the yellow, so I must go along the yellow from E to F. And then lastly, the only thing left would be D. Okay, so this similarity statement is important. If I was to put this in the wrong order, so I see how everything lines up, A, B, C, E, F, D, A, B, C, E, F, D. These have to line up the exact same. If I was to mix up these letters, then my similarity statement is incorrect. So I've identified the similar triangles. Now I need to find x. Well, if they're similar, then they must be proportional. And so I can simply say, well, I know that x minus 1 has to go with 27, just like 5 has to go with 15. And just use my highlighter real quick to show you how I know that, right? Those are both from the yellow side, and these are both from the green side, right? And notice that I have these two values are both from the top triangle, and these two values are both from the bottom triangle. Before I try to solve this, I can definitely reduce this, and that's what I want to do. I want to reduce this. I could reduce it by 5. We'll make this a 1 over 3. And now we can cross multiply. 1 times 27 is 27. 3 times x minus 1 is 3x minus 3. And I've seen a lot of students, when you cross multiply, you don't know what to do. You just put one of your products on one side and the other on the other, and you set them equal to each other. That's all you're really doing. Because really it's like multiplying both sides by 27, and it's like multiplying both sides by 3. That's all we're doing. All right, so now we just have some algebra here. I'm going to add 3 to both sides, and I get 30 equals 3x. Divide both sides by 3. And we get a solution, and that is that x equals 10. Beautiful. Okay, that's it for the first problem. Let's take a look at number 2. So number 2 is interesting because it's 2 triangles in one. I'm going to highlight the 2 triangles so you could see them. So we have the green triangle, and we have the blue triangle. All right, and kind of what I told you to do this with this one is to kind of just keep it in this formula of, like, if you did height over base, I don't know why I did a capital B there. I should have done lowercase b, but it doesn't matter. And then I said do small triangle and big triangle. And if you always put it in this format, you can't really go wrong. So let's go through this. What is the height of the small triangle? Well, that's 1. What is the base of the small triangle? Well, that's 2. What is the height of the big triangle? Well, that's 10. And then lastly, what is the base of the big triangle? Well, this is where students mess up. They think that it's x, but it's not. Think it's this whole triangle, so it's x plus 2. All right, now we have enough to go ahead and solve for x. We're going to cross multiply. 2 times 10 is 20. And 1 times x plus 2 is x plus 2. Subtract 2, and we get x equals 18. Boom. So remember, if you just pick... Now, this is not the only way to set it up, by the way. This is not the only way, but it's just, if you just pick a way and just be consistent with it, you'll be fine. Like, I could have put the big triangle here, small triangle here. I could have put base on bottom, height on... or base on top, height on bottom. It doesn't really matter. It's just about being consistent. All right. Let's go to number 3. All right, so in number 3, they don't really tell us much other than that they give us these 2 little symbols here telling these things are parallel. And if those are parallel, that actually means that these angles right here are alternate interior. And these angles here are alternate interior. And then, of course, these are vertical. Well, with that, we could kind of tell what sides have to line up. I'm going to use my highlighter to show you, but C to D is between the green and the blue, just like 16. C to B is between the green and the blue. We'll say A to C is between the red and the green, just like C to E is between the red and the green. Well, that's enough then to go ahead and set this problem up. So I'm going to say that 2x plus 20 goes with x plus 4 in the same way that 16 has to go with 4. I'll get my highlighter out and show you where I got that from. These are what I highlighted as the blue sides, and this is what I highlighted as the yellow side. Now, again, I think I could reduce this, and I would reduce it to 4 over 1. I'm going to leave it as a fraction just because my next step is to cross multiply. And so when I cross multiply, I can kind of see what I'm going to be multiplying by. So 4 times x plus 4 is 4x plus 16, and 1 times 2x plus 20 is just 2x plus 20. Now I have a pretty simple algebra. I'm going to subtract 2x from both sides, and I'm going to subtract 16 from both sides. 4x minus 2x is 2x, 20 minus 16 is 4, divide by 2, divide by 2, x equals 2. All right, but that's not all they wanted. Notice it says find x and the measure of the indicated parts. Here's the indicated parts. They wanted CE. So we could say CE is x plus 4, and now we know that x is 2. So CE would be 6. So we found x and the measure of the indicated parts. Okay, again, let's just recap how I knew what parts go with what. I first matched up the angles, and I knew certain angles had to go together because these are parallel lines, therefore these are alternate interior, and these are alternate interior, and these are vertical. So we can match up those angles, and then we can tell what sides have to go with what. These two have to go together, these two have to go together, because they match up what angles they're in between. That's how we can tell. All right, let's go to number 4. Okay, number 4 is another one of these ones. We're just going to do height, base, small triangle, big triangle, and we'll be good. So again, we have the small triangle and the big triangle. So my small triangle values go here, my big triangle values go here. Easy peasy. So the height of the small triangle is 5. The base of the small triangle is 3. The height of the big triangle is x, and the base of the big triangle is 3 plus 6, which is 9. Remember, I have to add these up to get 9. All right, pretty simple. Just going to cross multiply. And then solve. Divide both sides by 3, I would get 15. So x equals 15. Okay, pretty simple. Let's go on to the next page. All right, when you see that these two angles are marked to be the same, this little symbol, by the way, this is called theta. You'll see this a lot, especially in the next chapter. But all they're saying right here, all this little symbol means is, hey, these two angles are the same. Okay, so this is a triangle where the angle here has been bisected into two congruent angles. Well, therefore, we can use the angle bisector theorem. And the way I kind of summarized that for you guys, remember I said I want you to do side 1 over part 1 equals side 2 over part 2. Now there's a lot of different ways you could set this up. I mean, you could do side 1 over side 2, part 1 over part. It doesn't matter. Again, just as long as we're consistent. But what do I mean by that? So I mean that this is a side, so I'm going to call that side 1. I mean that this is only a part of a side, so I'm going to call that part 1. And I'm saying side 1, part 1 because see how they're touching each other? And then I'm saying this is side 2, and this is part 2. Well, once we have all the pieces, we could plug it in pretty easily. So side 1 we said is x, part 1 we said is 3.6, side 2 we said is 2.81, and part 2 we said is 2.3. And I'm just going to go through and highlight all these pieces so we can see. So, right, this is, all we're doing is just kind of placing things right into this formula. Okay. If we just use the same thing every time, we're in good shape. This might be something you want to write on your 3x5 card. So I could cross multiply, or in fact the x is actually already on top, so I don't even have to cross multiply both sides. I could just multiply both sides by 3.6, and really that's enough to solve this equation. So from here I'm just going to my calculator, and I'm just going to do 2.81 times 3.6 divided by 2.3. And I get a number with a lot of decimals. I get x equals 4.398260087. Okay, but what does it say? It says round your answer to 2 decimal places. So that means I only want to round to these two, and the 8 is going to make this round up. So we're going to say that the answer is 4.40, which is kind of weird because we don't need to put the 0 there, so we could actually just say 4.4 then. All right, and we have answered question 5. Okay, let's go to number 6. All right, so 6 is interesting, and the mistake that students will often make with 6 is they'll look at this and they'll say, oh, look, that's a rectangle. This is a right triangle. But there's nothing that actually tells you it's a right triangle. All they do tell you is that BCD is similar to FDE. That's all they tell you. And they want you to find the perimeter of the given triangle below. That given triangle is BCD. So that's what they want you to find the perimeter of right there. But we know that it's similar to this triangle. And they give us a bunch of pieces, okay? So let's write in everything they give us. They say that EF is 3, DE is 9, FD is 5, and CD is 15. Well, if that's all true, then we could find these other pieces, and I'm just going to call them X and Y. So let's call this X, let's call this Y. If these two triangles are similar, I could use a proportion to solve for X, a proportion to solve for Y, add them all up, and I'll have my perimeter, okay? So let's do that. Let's say, right, we could say X has to go with 3, just like 15 has to go with 9. And so I'm going to write that proportion. I'm going to say X goes to 3, just like 15 goes to 9. And the thing that I see right away is I'm pretty sure I could reduce that. Yeah, I can by 3s. So if I take a 3 out of 15, it'd be 5. And if I take it out of there, it'd be 3. And actually, this is enough to just solve for X. Hopefully, you can just see it. What we're saying here is, hey, something divided by 3 equals 5 divided by 3. Well, the something must be 5. If you're not sure about that, let me just show you how we could prove it. Cross multiply. I get 15 equals 3x. Divide by 3, divide by 3. Hey, 15 divided by 3 is 5. Really, we didn't need to do all that. We could have just seen, hey, these match now, so the x has to be 5. All right, I got the x is 5. Now, I need to find the y. Well, just like I did with the x's, I could do the same thing with the y's. So let's say y is to 5 as 15 is to 9. Y is to 5, just like 15 is to 9. And once again, the 15 and the 9 can reduce to 5 over 3. And we could cross multiply. And we get 25. And cross multiply. And we get 3y. Divide by 3, divide by 3. We get 25 thirds. This is one where you might actually want to convert it to a fraction. So 25 thirds is like 8 1/3 or 8.33 repeating. Because remember, at the end of the day, they want the perimeter of the given triangle. That's BCD. The perimeter is just all the sides added up. So 15 plus 5 is 20, plus 8 1/3 is 28 1/3. So the perimeter of this triangle is 28 1/3. And again, I got that by just doing 15 plus 5 plus 8 1/3. All right, one more question to do on here. Let's go for it. Find the length of AB. Okay, so as we look at this, what they really want, right, the length of AB, they want this total distance here. That's what AB is. Well, in order to do that, I'm going to need to know what DB is. Okay, so I'm going to call DB X for now. Now, this is one of those problems where we'd be best suited to just simply redraw all these triangles. So I'm going to try to highlight all these triangles so you can see all the different ones. We have a red one. We have a blue one. And we have a green one. Okay, I'm going to redraw them all so we can we get an idea of what's going on. So the red one, put the right angle up here. If I did that, then this would have to be A, this would have to be D, this would have to be C. And notice I put the, this is the shorter side, so I'm putting the short side on top and the middle side along the side here, hypotenuse in the bottom left. I want to do that for all of them. Let's go ahead and fill in what I know about this. I know that this is 10.8, and I know this is 14.4. Okay, let's draw the blue one. Same orientation, right? I'm trying to match up the orientation. So the right angle is D, but now the short side is from D to C, and the long side is D to B. And we know DC is 14.4, and we know that we call DB X, right? We're going to have to find this, add it to 10.8, and then we'll get our answer. Well, we actually don't need to draw the green triangle. We could draw the green triangle, but it's not really relevant for what we need. We just need to know what X is, and we have enough at this point to find out what X is, because we can see that 10.8 goes to 14.4, just like 14.4 goes to X. So let's make a proportion. 10.8 goes to 14.4 in the same way that 14.4 goes to X. Okay? 10.8, 14.4, 10.8, 14.4, 14.4 to X, 14.4 to X. All right. I'm just going to cross multiply here. So 14.4 times 14.4 is 207.36 equals 10.8x divided by 10.8. Again, I'm using my calculator here, and I get that x is 19.2. Now here's the trouble. Students are going to get the solution, and they're going to be like, oh, I'm done, I found the answer, it's 19.2. Wrong. What are they really asking for? Remember, they're asking for AB. AB is 10.8 plus 19.2. 10.8 plus 19.2. So add those together and you get a beautiful 30. That's the answer that we're looking for. Okay, hopefully that helps. The one other thing I would tell you is there is a fill-in-the-blank proof. So I would go back to that. Not the very last skill, not like the very last skill on Khan with the complicated proofs. But the one earlier on when we were just kind of proving that triangles were similar. There is a one question that is similar to that skill where you're going to fill in certain parts to a proof. Other than that, this is a majority of what's going to be on your quiz. So good luck.